Today we will learn the representation of rational numbers on the number line. In the previous class, we represented integers on the number line. Positive integers are represented on the right of 0 and negative integers on the left of 0 on this number line. The distance between any two integers is called a unit distance. Let's make 10 equal parts of the unit distance between 0 and 1. In this way, each of these parts will be 1 by 10th part of the unit distance. If we start with 0, number 1 by 10 can be shown on the number line by taking one part from it. In the same way, two parts can be shown by 2 by 10, 3 by 10, etc. Similarly, by taking 10 parts out of 10, you can show a complete, that is 1. Just now, we have represented rational numbers on the number line. Let's understand in detail the representation of rational numbers on the number line. Suppose we have to represent the rational number minus 5 by 6 on the number line. Pause the video first and try to represent it on the number line. Let me tell you, here the rational number minus 5 by 6 is a negative rational number. We know that on a number line, a number smaller than a number is represented on its left side and a larger number on its right. Since the values of all negative rational numbers are less than 0, their positions are to the left of 0. Therefore, the position of minus 5 by 6 will also be on the left of 0. Let's ignore the minus sign for a while. Now, we see that the numerator 5 in 5 by 6 is smaller than 6. From this, it is known that 5 by 6 is smaller than 1, that is, less than a unit. This tells us that the place of minus 5 by 6 is between 0 and minus 1. To find the exact location of minus 5 by 6, we will divide the distance between 0 and minus 1 into 6 equal parts. In this way, the distance between any two consecutive parts of these 6 parts will be 1 by 6. The fraction of rational number minus 5 by 6 tells us that we have to take 5 parts of 1 by 6 distance to the left of 0. This will give us the exact location of minus 5 by 6. Now, will you be able to represent 15 by 4 on the number line? Pause the video and try it. Let me tell you, 15 by 4 is a positive rational number, so it is to the right of 0. We can write 15 by 4 as 3 and 3 by 4. This shows us that these rational numbers are between 3 and 4. To find the exact location, we will divide the unit distance between 3 and 4 into 4 equal parts. Now, we will show the number 3 by 4, that is 15 by 4, by taking 3 whole and 3 parts of 1 by 4th distance. Now, you will be able to represent any rational number on the number line. Today we have learned the representation of rational numbers on the number line. In the next video, we will see some interesting examples related to these. Today we will see some interesting examples related to representation of rational numbers on the number line. There are equal distances between any two points on the number line shown below. Find out the rational numbers denoted by points P and Q. there are equal distances between any two points on the number line shown. To find this distance, we will subtract the number to the left of it from a number. For example, here 0 minus 1 by 7 is equal to 1 by 7. That is, distance between 0 and minus 1 by 7 is 1 by 7 units. This tells us that if we move to the left of 0 on the number line, the numbers are decreasing by 1 by 7. Here we are getting point P by moving 1 by 7 distance to the left of minus 6 by 7. So, this will represent the point minus 6 by 7 minus 1 by 7 is equal to minus 7 by 7. That is, the number will represent minus 1. Similarly, now you find out which rational number will fall at point Q. Find it by yourself. Next example, represent 35 by minus 8 on the number line. If the denominator of a rational number is negative, first we make it positive. For this, we multiply both the numerator and denominator by minus 1 so that there is no change in the value of the number. This will give us the rational number minus 35 by 8. Minus 35 by 8 is a negative rational number, so its position is to the left of 0. We can write minus 35 by 8 as minus 4 and 3 by 8. This shows us that the position of given rational number is between minus 4 and minus 5. To find the exact location, we divide the unit distance between minus 4 and minus 5 into 8 equal parts. We will denote minus 4 and 3 by 8 means minus 35 by 8 by taking 3 parts out of these 8 parts. Next example, each of points P, Q, R, S denote a rational number of 3 by 2, minus 4 by 5, 10 by 3 and minus 7 by 4, but not in given order. Point Q should neither be at extreme left nor at extreme right. Point R is to the immediate right of point Q. Point P is to the right of point R. Find the rational numbers represented by each point and arrange them on the number line. Pause the video and try to solve this puzzle by yourself. Let me tell you. Let us first arrange the points P, Q, R, S in the correct order from the given information. The first information tells us that point Q should neither be at extreme left nor at extreme right. That is, it must be somewhere in the middle. We can say that point Q will be either at this place or at this place. Let us show these two possibilities as follows. From the second information, we find that point R is at the immediate right of point Q. In this way, we can show the point R at this place or at this place. From the third information, we find that point P is to the right of point R. In this case, point P can be placed to the right of point R, but in this case, it is not possible to do so. So, these types of arrangement are wrong. Now, we will place the remaining point S in the blank. This will give us the order of points SQRP. Similarly, we will now arrange the given rational numbers in the increasing order. For this, we will use the number line, that is, we will represent the rational numbers given on the number line. 3 by 2 is a positive rational number. We can write this as 1 and 1 by 2. Hence, its position is between 1 and 2. To find the right place, we will divide the distance between 1 and 2 into as many parts as the denominator, that is 2 parts. Since the numerator is 1, by taking one of these 2 parts, we will denote number 1 and 1 by 2 or 3 by 2. Similarly, we will denote minus 4 by 5, 10 by 3 and minus 7 by 4. Considering the order of rational numbers and the order of given points, we can now say that point S is the rational number, minus 7 by 4, point Q is the rational number, minus 4 by 5, point R is the rational number, 3 by 2, and point P represents the rational number 10 by 3. So today we have seen some interesting examples related to representation of rational numbers on the number line.
Hello friends, and welcome to this video. In today's video, we will learn about the closure property of rational numbers. Children, you must have read about numbers in previous classes. Now let us revise this once. Children, what are natural numbers?
Sir, the numbers which we can count are called natural numbers. Like we have 1, 2, 3, 4 and 5 fingers in one hand.
Well done, Rahul. Children, now let us move ahead and add 0 to these natural numbers. Now, who will tell what we call such a group of numbers?
Sir, we call this group of numbers whole numbers.
Mohan, you are right. Children, you may all know that sometimes we have to use negative numbers. Like during winter, the temperature drops to 0 in many places. This is represented by a negative number, like minus 2 degrees Celsius. Now if we add negative numbers to whole numbers, then what is the group of numbers called?
Sir, we call this group of numbers integers.
Well done, Rahul. You remember everything from the previous class. Children, you have learned about fractions, where we used to write a number as a numerator and denominator. Now look at this number line. If we go half a step right from 0, we get 1 by 2. But when we go to the left from 0, we get negative numbers. For example, going half a step left, we will get minus 1 by 2. You can see here that it is neither an integer nor a fraction, because the numerator and denominator must be positive to be a fraction. So what is this number?
Sir, this is a rational number.
Well done, Mohan. Children, now can you tell the definition of rational numbers?
Sir, rational numbers are numbers that can be written in the form of P by Q, where P and Q are integers and Q is not equal to 0. Sir, why can't Q be equal to 0?
Mohan, if I ask you the value of 8 by 2, what will you do?
Sir, I will search for a number which when multiplied by 2 gives me 8, and that number is 4.
Well done, Mohan. Now, what is the value of 8 by 0?
Sir, this cannot be found. I can't find any number which gives me 8 when multiplied by 0.
Rightly said, Mohan. And we call such a number undefined.
Sir, I have understood now.
Children, you have already learned about closure property in the previous class. Can you tell me, what is closure property?
Whenever we use an operation on the numbers of a set and the resulting answer also falls within the same set, then we consider that set to be closed for that operation.
Well done, Rahul. Children, now add these integers and see, will we get an integer after adding them? You can pause the video and try. Children, what can we say about the closure property of integers?
Sir, integers are closed under addition because every time we add two integers, we will get another integer.
Well done, Mohan. Are rational numbers closed under addition? Let's examine it. We take two rational numbers. What will we get by adding 1 by 4 and 2 by 3? You too try to solve this question. Children, is this also a rational number?
Yes, sir, it is a rational number.
Children, now add the following rational numbers and observe the result. Children, you will see that adding any two rational numbers gives another rational number because rational numbers are closed under addition. Children, in this session, we learned about different types of numbers such as natural numbers, whole numbers, integers, and rational numbers. We also verified the closure property under addition of rational numbers. In the next video, we will discuss closure properties of rational numbers under subtraction and multiplication. That's all in this session. See you in the next session. Thank you. Hello friends, welcome to this video. We have previously learned that rational numbers are closed under addition. Are they also closed under subtraction and multiplication? Let's see. Children, we have discussed the closure property of rational numbers under addition. Now let us discuss it with respect to subtraction. Children, subtract 8 from 3.
Sir, the answer is -5.
Well done, Rahul. Children, now look at this table. Here 3 and 8 are natural numbers. But the answer obtained by their subtraction is not a natural number. Children, by looking at this table, you can say that subtracting two natural numbers does not necessarily give a natural number. Sir, it means that natural numbers are not closed under subtraction. Yes, Mohan. Can you find out the same about whole numbers and integers using this method?
Yes, sir. Even whole numbers are not closed under subtraction.
Well done, Mohan. You have answered it correctly. Children, you may also remember what you had studied in the last class about integers. Integers are closed under subtraction.
Sir, do rational numbers have the same property as integers?
Let's see. Let us now take two rational numbers such as 5 by 2 and 2 by 5. Subtract them and tell me the answer.
Sir, the answer is 21 by 10. And this is also a rational number.
Children, let's take another example. Let's find 4 minus 2 by 3. You too should solve this question. Children, did you also get 10 by 3, which is a rational number? Children, now look at these numbers. Did you get rational numbers as the result? You too should solve this question. Children, you must have obtained a rational number by subtracting these numbers. Because rational numbers are closed under subtraction. You can also do this for other rational numbers. Now children, we shall discuss about closure property under multiplication. We will take two rational numbers. What will you get if you multiply 2 by 7 and 3 by 5?
Sir, we will get 6 by 35, and this is also a rational number.
Children, will you get a rational number if you multiply -1 by 3 and 2 by 5?
Yes, sir, this time too we have got a rational number.
Children, multiply these numbers now. You too should solve this question. Children, this time too you will get a rational number after multiplying these numbers. This is because rational numbers are closed under addition and subtraction as well as multiplication. Children, so far we have discussed the closure property of rational numbers under subtraction and multiplication. In the next video, we will discuss closure property under division. That's all in this session. See you in the next video. Thank you. Hello friends, welcome to this video. So far we have learned that rational numbers are closed for addition, subtraction and multiplication. Are they closed under division? Let's find out. Children, today we will discuss the closure property under division of rational numbers. Now let's divide 15 by 20. Can you tell the answer?
Sir, the answer is 3 by 4.
Well done, Rahul. Children, now look at this table. You all know that 15 and 20 are natural numbers, whole numbers and integers. But 3 by 4 is neither a natural number, a whole number nor an integer. Children, what do you understand from this table?
Sir, this table shows that natural numbers, whole numbers and integers are not closed under division.
Well done, Rahul. You have given the right answer.
Sir, but is this true with the rational numbers too?
Let's find out. Let's divide any two rational numbers. For example, what will we get if we divide 2 by 7 by 5 by 4?
Sir, we have got 8 by 35, and this is a rational number.
Children, solve these questions in your notebook. You all try solving them. Hope your answers are rational numbers. Children, what did you learn about the closure property through these examples?
Sir, whenever we divide two rational numbers, we always get a rational number as the answer. That is why we can say that rational numbers are closed under division.
No, Mohan. This may not always be true. Let me explain. Children, is 0 a rational number?
Yes, sir, because we can write 0 as P by Q, where Q is not equal to 0. Q can be any number, such as 2.
Let's divide a rational number by 0, such as 2 divided by 0. Will we still get a rational number?
We can also write 2 divided 0 as 2 by 0. which gives us an undefined number.
Right answer, Mohan. What did you find out from this?
Sir, this means that it is not necessary that we will get a rational number by dividing two rational numbers. Sir, does this mean that rational numbers are not closed under division?
Yes, children. Rational numbers are not closed under division. But if we do not include 0, then all other rational numbers can be considered to be closed under division. Children, till now we have understood the closure properties of rational numbers for all operations, and we have observed that rational numbers are closed under addition, subtraction and multiplication, but not closed under division. This session ends here. Thank you. Friends, welcome to this video. Today we'll learn about the commutative property of rational numbers. Let's see what is happening in class today. Children, Rahul went from Delhi to Kanpur for some work and then from Kanpur to Prayagraj. Distance from Delhi to Kanpur is 495 km and the distance from Kanpur to Prayagraj is 205 km. So how much distance did Rahul traveled to reach Prayagraj from Delhi? Children, you must have got the answer as 700 kilometers. Now when Rahul had to come back, he went to Kanpur from Prayagraj and then reached Delhi from Kanpur. So children, can you find out the distance he traveled? Yes, you are right, 700 kilometers. Children, here we can see that Rahul covered equal distance in both the situations. While adding these numbers here, we see that changing their order did not change the answer.
Sir, two integers are being added here.
That is why in every case the sum of the equations is the same.
Because the addition of integers
Is commutative.
Rightly said, Sohan. Now explain to everyone the meaning of commutative property.
Sir, commutative means that even after changing the order of numbers in an operation, the result doesn't change. That is, the change of order doesn't affect the result.
As we have seen here, if we add these two integers in any order, their sum does not change.
If we add or multiply any two integers such as a and b in any order,
There is no change in the answer.
because the addition and multiplication of integers are commutative.
You are right, Sohan. Sohan, in the last class, we learned about the commutative property of natural numbers, whole numbers, and integers. Now let's discuss the commutative property of rational numbers. Rational numbers are numbers that can be written in the form of p by q, where p and q are integers and q is non-zero number, such as 4 by 7, minus 10 by 49, etc. We can also write natural numbers, whole numbers, and integers as p by q. Here, we can write 1 as the denominator.
So these are also rational numbers.
Let us now discuss the commutative property.
Of addition of rational numbers.
Suppose we have two rational numbers.
Now let's add them in this order.
How do we add such numbers? Like we used to add fractions, with the help of the least common multiple, LCM. Here the least common multiple of the denominator is 12. Adding these, we will get the answer 11 by 12. Now let's change their order and again add them. We will see that the answer will still be 11 by 12. Children, now you add the numbers given on the screen in this order. Keep in mind that the number 5 that is in the first question here can also be written as 5 by 1. Pause the video and solve these questions and write the answers. These are the results. Now change the order of these numbers and add them again.
Sir, even after changing the order, our answers are the same.
Children, you can all see that changing the order of addition of rational numbers did not affect our answer.
because the addition of rational numbers is commutative.
That is why we can add any two rational numbers like A and B in any order. Children, but is the subtraction of rational numbers also commutative? First, let's take two rational numbers such as 3 by 4 and minus 5 by 6. Now first subtract minus 5 by 6 from 3 by 4, which we will do in this way. Next, change the order of the numbers and subtract 3 by 4 from minus 5 by 6 and state the answer.
Sir, we have got a different answer in both the cases.
You are right, Mohan. Solve all the questions given here. Please pause the video and solve these questions and write your answers. Now change the order of numbers in each question and solve them again.
In each of the given questions, our answer changes whenever we change the order of numbers.
We can see here that changing the order of numbers in subtraction changes our answer, because subtraction of rational numbers is not commutative. That is why we can say that
For any two rational numbers, A and B, A minus B is not equal to B minus A.
let's go ahead and discuss the next operation, multiplication. Is multiplication of rational numbers also commutative? Let's see. For this, we take two rational numbers. Multiply both these numbers.
The answer is 35 by 12.
Now let's change the order of these numbers.
Sir, our answer is still 35 by 12.
Now all of you solve these questions. On solving these questions, you must have got these answers. Now change the order of these numbers and multiply.
Sir, swapping the numbers did not change our answer.
You are right, Mohan. This is because the multiplication of rational numbers is commutative.
We can say that
A multiplied by B is equal to B multiplied by A for any two rational numbers A and B. Children, now let's check the commutative property of rational numbers in division. Now look at the two rational numbers given here and divide them in this order, keeping in mind that 2 to the power of 2 is 4. Now change the order of these numbers and then divide them. What did you understand from this?
Sir, here the answer in both situations is the same.
Children, considering this one example, can we say that the division of rational numbers is commutative? Let's see some more examples. Children, now look at these rational numbers and divide them in the same order. Write the answers in your notebook. Now change the order of these numbers and divide them again. Now compare the answer with the answers that you have written in your notebook.
Sir, on changing the order of this question, our answers are different. When we divide 0 by 5, the answer is 0. But dividing 5 by 0 gives the answer 5 by 0.
by dividing 5 by 0, we get an undefined answer. Here, with the help of examples, we have learned that when we divide two same numbers, we get the same answer even if we change their order. But generally, if we change the order while dividing numbers, our answer changes. This is because division of rational numbers is not commutative. So friends, in this session, we learned that the sum and multiplication of rational numbers is commutative, but subtraction and division is not commutative. In the next video, we will see some examples related to commutative property of rational numbers. That's all in this session. See you in the next session. Thank you. Friends, welcome to this video. Today we will see some examples based on the commutative property of rational numbers. In the previous video, we learned that the sum and the multiplication of rational numbers are commutative, but the subtraction and division are not commutative. Come, let's see what is happening in this class. Children, look carefully and tell which of these options is correct. All of you solve these questions.
Sir, we can multiply rational numbers in any order. Therefore, the first option is correct.
Absolutely correct. What do you think about the second option?
Sir, the second option is wrong because the subtraction of rational numbers is not commutative. We can see here the answer on the LHS is 1 by 4. And the answer on RHS is minus 1 by 4. But sir, the third option is correct. The answer on LHS is 29 by 20. And the answer on RHS is also 29 by 20. This is because the sum of rational numbers is commutative. And the fourth option is wrong. We can see here the answer on the LHS is 5 by 6 and the answer on RHS is 6 by 5. It is not equal.
They are reciprocal of each other.
Sohan, your answer is correct. But what do you think about the last option?
Sir, if we look at the left side, that is LHS, then we can write square root of 9 is equal to 3 and square root of 25 is equal to 5. In this way, we can write square root of 9 by 25 as 3 by 5. Now we can write LHS as follows, which is equal to 3 by 5 multiplied by 7 by 4. We know that the multiplication of rational numbers is commutative. So we can also write 3 by 5 multiplied by 7 by 4 as 7 by 4 multiplied by 3 by 5. Because changing the order will not change the answer. We can see that in our option, LHS is equal to RHS. That is, the last option is correct.
Children, now fill in the blanks. All of you try solving this question. Sir, the answer to this question is 11 by 9. How did you get that, Mohan?
Sir, in this question, we have to find a number that when multiplied by the square root of 4 by 3 gives an answer equal to the product of 11 by 9 and 2 by 3. The square root of 4 is 2, so we can write it this way. We can also write the given question as, solve it now. We know that the multiplication of rational numbers is commutative. So if we write 11 by 9 on the blank space here, we can see that the left side is equal to the right side. That is, our answer is 11 by 9.
Children, in this video, we saw examples related to commutative property of rational numbers. That's all in this session. Thank you.
Today we will learn the associative property of various operations performed on rational numbers. Associative properties are related to the use of parentheses in operations. Associative means being together. Here, it means keeping the numbers together, means forming their groups. We do this using brackets. To perform proper operations on numbers, we need to know about use of parentheses. That is, understand the associative property. In the previous class, we learned that for performing addition on integers, we can group them in any ways, that is, with the help of parentheses, any two numbers can be kept together. We will get equal results in every situation. So we say that for integers, addition of integers is associative. Like addition, multiplications for integers are also associative. But subtraction and division for integers are not associative. Today, we will talk about associative properties of various operations performed on rational numbers. Let us first talk about the addition of rational numbers. Suppose the amount of water in 3 bottles is 1 by 6 liter, 2 by 5 liter, and 2 by 3 liter respectively. If we want to find the total amount of water, then we have to add these. That is, we have to find the result of 1 by 6 plus 2 by 5 plus 2 by 3. To simplify this, we can create groups like this or like this. If we first make a group of 1 by 6 and 2 by 5, then the sum will be 17 by 30. By adding the number 2 by 3 to it, we will get the result 37 by 30. If we make a group of 2 by 5 and 2 by 3 and add them, the sum will be 16 by 15. Adding 1 by 6 with this, we will get the result 37 by 30. From both the conditions here, we find the total amount of water in all the bottles is 37 by 30 liters. Since the results are same in both cases, we can say that the addition of rational numbers can be made by grouping in any way. That is, the addition of rational numbers is associative. So, to summarize, for any rational numbers a, b, c, a plus b in brackets plus c is equal to a plus in brackets b plus c. Are subtractions for rational numbers also associative? Let's find out. Suppose Aditi has 4 by 5 chocolates. Out of that, she gives 2 by 5 part to Ankit and 3 by 10 to Suman. So tell me, how much chocolate will be left with Aditi? We can represent the given situation in this way. Let's solve this by forming different groups. If we make a group of 4 by 5 and 2 by 5, then we will get 2 by 5 as a result of 4 by 5 minus 2 by 5. If 3 by 10 is subtracted from it, the result will be 1 by 10. Now, pause the video and find out if it is solved by forming a group of 2 by 5 and 3 by 10, what will be the result? Let me tell you, we can simplify it in this way. We will get the result 7 by 10. Here, the results are not the same in both cases. Therefore, any three rational numbers a, b, and c cannot be grouped in any way. It is necessary to subtract them in the given order. we can say that subtractions for rational numbers are not associative. Means, here the result of the first case is correct and the result of the second case is wrong. So, we can say that Aditi has 1/10 chocolate left. Now, pause the video and multiply any three rational numbers by grouping them in different ways. Are the results equal? So, are multiplications associative for rational numbers? Absolutely right. Rational numbers A, B, C can be multiplied by grouping in any way. The result will always be equal. Therefore, we can say that multiplications for rational numbers are associative. Here, the results in both cases are equal. Similarly, let us find out whether division is associative for rational numbers. If we simplify 6/7 divided by 4/3 divided by 1/12, in this way, the result will be 54/7. But if we simplify it in this way, we will get the result 3/56. In both the cases, here the result is not equal. So, the rational numbers A, B, C cannot be divided by grouping in any way. It is necessary to do this in the given order only. Therefore, we can say that for rational numbers, division is not associative. In this way, here, the result of first case is true and the result of second case is false. Now, you must have understood that the addition and multiplication for rational numbers is associative, but subtraction and division are not associative. Today we have learned the associative property of various operations performed on rational numbers. In the next video, we will understand it better by some interesting examples. Today we will see examples related to associative property of different operations on rational numbers. Manish cut a rope into 4 pieces. The length of pieces was as follows. Can you tell what is the total length of the rope? The length of 4 pieces of rope is 7/9 meter, 5/12 meter, 11/12 meter and 5/3 meter. Therefore, the total length of the rope will be the sum of these 4 pieces. Total length of rope is equal to 7/9 meter plus 5/12 meter plus 11/12 meter plus 5/3 meter. Here we see that denominators of 5/12 and 11/12 are equal. So it is easy to add them. Since the addition is associative for rational numbers, we can simplify this bracket first by taking 5/12 and 11/12 in parenthesis. This will give us result of the brackets 16/12, which we can write 4/3. Now we will take parenthesis on 4/3 and 5/3. Solving 4/3 plus 5/3 will result in 9/3, that is 3. Now 3 plus 7/9 is equal to 3 and 7/9, that is 34/9. Therefore we can say that total length of the rope is 3 and 7/9 meters. Next example. Rahul gave 2/3 portions of his 1 and 4/7 chocolate to Amit. Amit gave 3/4 of the chocolate he had to Neeta. Find how much chocolate Neeta received. Rahul has 1 and 4/7 chocolate, that is 11/7 chocolate. Amit is getting 2/3 part of this chocolate. That is, Amit is getting 2 by 3 multiplied by 11 by 7 chocolate. Neeta is getting 3 by 4 part of it. So chocolate obtained by Neeta is 3 by 4 multiplied by 2 by 3 multiplied by 11 by 7. Let's solve it. Multiplication for rational numbers are associative. So we can group here as follows. By simplifying the parenthesis, we get the rational number 1 by 2. Now we multiply 1 by 2 and 11 by 7. This will give us the result 11 by 14. In this way, Neeta gets 11 by 14 of the total chocolate. Next example, Sunita and Manisha were solving 68 divided by 17 by 25 divided by 17 by 25. Both of them simplified it as shown, but the results of both came differently. Can you tell whose answer is correct and why? Divisions for rational numbers are not associative. That is, groups cannot be created in any way in operation of a division. Here, Manisha has formed the wrong type of group, due to which she has got the wrong answer. Rational numbers must be divided in given order only. Sunita must be knowing this. So, she has got the correct answer. So, today we have seen examples related to associative property of different operations on rational numbers. Today we are going to learn about identity and inverse of rational numbers. Identity means recognition. Often in mathematics, the identity of numbers gets changed because of different operations on it. Like adding 2 with 5 changes the value of 5 to 7. Similarly, adding 2 by 3 in rational number 5 by 3 changes its value to 7 by 3. Identities of numbers do not change in some special cases. Like in all rational numbers, 0 is the only number which when added to any number gives an answer as the same number it is added to. The identity of rational numbers is not changed. We say that 0 is additive identity for rational numbers. In brief, for rational number p by q plus 0 is equal to 0 plus p by q is equal to p by q. For example, the answer of 2 by 3 plus 0 or 0 plus 2 by 3 is 2 by 3 only. The answer of minus 15 by 4 plus 0 or 0 plus minus 15 by 4 is minus 15 by 4 only. Similarly, in all rational numbers, 1 is the only number which if multiplied to any rational number gives an answer as same rational number only. The identity of that rational number does not change. We say that 1 is multiplicative identity for rational numbers. In brief, for a rational number p by q multiplied by 1 is equal to 1 multiplied by p by q is equal to p by q. For example, answer of 2 by 3 multiplied by 1 or 1 multiplied by 2 by 3 is 2 by 3 only. Answer of minus 15 by 4 multiplied by 1 or 1 multiplied by minus 15 by 4 is minus 15 by 4. Inverse means opposite. Let's understand its importance in mathematics. Let's take a rational number 3 by 7. If we add a rational number minus 3 by 7 to it, then we get an answer as 0. We can say that adding 3 by 7 and minus 3 by 7 makes the value of each other 0. Therefore, these are negative or additive inverse of each other. To summarize, if addition of any two numbers is 0, then these two numbers are additive inverse of each other. Like here, rational number minus p by q is additive inverse of rational number p by q. Similarly, rational number p by q is additive inverse of minus p by q. Negative or additive inverse of a rational number is obtained by multiplying minus 1 means changing the sign of rational number. Now consider the rational number 10 by 11. Can you tell me a rational number which when multiplied with this 10 by 11 gives as answer 1? Think. Absolutely correct. Such a number is 11 by 10. If multiplication of a rational number a by b with another rational number c by d is 1, then we can say that rational numbers a by b and c by d are multiplicative inverse or reciprocal of each other. The multiplicative inverse of non-zero rational numbers is obtained by interchanging its numerator and denominator. So now you must have understood about additive identity, multiplicative identity, additive inverse, and multiplicative inverse. Today we have learned about identity and inverse of rational numbers. In the next video, we will see examples on it. Today we will see examples on identity and inverse of rational numbers. Find out the multiplication of additive inverse and multiplicative inverse of minus 6 by 7. If addition of any two rational number is 0, then both rational numbers are additive inverse of each other. So, can you tell me additive inverse of minus 6 by 7? Think. Absolutely correct. Since minus 6 by 7 plus 6 by 7 is equal to 0, therefore, the additive inverse of minus 6 by 7 is 6 by 7. Similarly, if multiplication of any two rational numbers is 1, then both rational numbers are multiplicative inverse of each other. Since minus 6 by 7 multiplied by minus 7 by 6 is equal to 1, therefore, we can say that multiplicative inverse of minus 6 by 7 is minus 7 by 6. Can you tell me why we didn't change the place of negative sign? Think. Absolutely correct. Because multiplicative inverse of minus 6 by 7 is 7 by minus 6. But if we multiply minus 1 to the numerator and denominator, then there will be no change in the value of number and we get minus 7 by 6. Remember that generally we represent negative signs with numerator only. Now we will multiply additive inverse 6 by 7 and multiplicative inverse minus 7 by 6 of minus 6 by 7 with each other. This will be 6 by 7 multiplied by minus 7 by 6 is equal to minus 1. Therefore, minus 1 is the answer to the given question. Next example, identify the rational number which when added to 3 by 10 gives answer 3 by 10. We know that 0 is the only rational number which if added to any number makes no change in the value of the rational number. Therefore, for addition of rational numbers, 0 is the additive identity. Now, if we add 0 to 3 by 10, 3 by 10 plus 0, then there is no change in the rational number 3 by 10. The required rational number is 0. Next example, simplify. First, we will solve the multiplication operation. Simplifying 7 by 8 multiplied by 2 by 3 gives answer 7 by 12. Now, with the help of commutative property of addition, we will change the order of numbers and form their groups with the help of associative property. In this bracket, we see that 3 by 4 and minus 3 by 4 are additive inverse of each other. Therefore, their addition is 0. Similarly, addition of brackets is also 0. Since 0 is the additive identity, therefore, in addition, if 0 is added to 4 by 9, then the answer is 4 by 9 only. Therefore, the answer is 4 by 9. So, today we have seen examples on identity and inverse of rational numbers. In the next video, we will see misconceptions on this. Today we will see some misconceptions related to identity and inverse of rational numbers. Misconception 1. Which of the following statement is true for rational number p by q? Students often confuse between additive identity and additive inverse. They think that just like an object looks in a mirror, the same applies to the rational number p by q. Minus p by q is the additive identity of p by q. Therefore, they give answer as option 1, which is wrong. Remember that 0 is additive identity for rational number because addition of 0 to any rational number makes no change in the value of rational number, means its identity is not changed. Similarly, if addition of any rational number a by b with rational number c by d is 0, then a by b and c by d are called additive inverse of each other. Here, addition of p by q with minus p by q gives answer as 0. Therefore, for p by q, minus p by q is the additive inverse. Therefore, option 2 is the correct answer. Misconception 2. Which of the following examples assures that 1 is the multiplicative identity of rational numbers? For rational numbers, 1 is the multiplicative identity. Many students just memorize the concept of multiplicative identity. They do not understand its meaning. By looking at the first option, they think that here multiplication operation is performed and the answer obtained is 1. Therefore, this option is an example of multiplicative identity. For this reason, they give the answer as option 1, which is a wrong answer. Remember that if any rational number is multiplied with 1, then the answer is same rational number. That is, there will be no change in the value of that rational number. Therefore, we can say that the rational numbers 1 is a multiplicative identity. Means here option 2 is the correct answer. So today we have seen some misconceptions related to identity and inverse of rational numbers. Today we will learn distributivity of multiplication over addition and subtraction of rational numbers. Just think, Nishant buys 2 identical bottles of juice and 2 identical chocolates from a shop. If a juice bottle costs 22 rupees and chocolate costs 15 rupees, what will be the total value of all the items? Think. Let me tell you, you can find it in 2 ways. You can double this by adding the cost of a bottle of juice and cost of the chocolate, or you can add them by finding the cost of 2 bottles of juice and the cost of 2 chocolates separately. In both cases, you will get the same result. We can say that 2 multiplied by 22 plus 15 is equal to 2 multiplied by 22 plus 2 multiplied by 15. Here, the distribution of multiplication over addition is done. Multiplication can also be distributed over addition in rational numbers. Let us understand this with an example. Suppose we want to multiply 2 by 3 by minus 4 by 5 plus 7 by 5. We will do it in this way, or we will do it in this way. We are getting the same result in both cases. So we can say that 2 by 3 multiplied by minus 4 by 5 plus 7 by 5 is equal to 2 by 3 multiplied by minus 4 by 5 plus 2 by 3 multiplied by 7 by 5. In general, for any three rational numbers a, b, c, a multiplied by b plus c is equal to a multiplied by b plus a multiplied by c. This is called distributivity of multiplication over addition. Now pause this video, take your notebook and pen, and take three rational numbers on the notebook. Suppose the first rational number is a, second is b, and third is c. Now you can find the result by placing the values taken in the place of abc in a multiplied by b minus c. Now you can find the result by placing the values taken in the place of abc in a multiplied by b minus a multiplied by c. Did you get the same result in both cases? What does this tell you? Think. Sure, we can say that for any three rational numbers a, b, c, a multiplied by b minus c is equal to a multiplied by b minus a multiplied by c. We call this distributivity of multiplication over subtraction. Now you must have understood distributivity of multiplication over addition and subtraction. So today we have learned distributivity of multiplication over addition and subtraction of rational numbers. In the next video, we will see some examples related to them. Today we will see some examples related to distributivity of multiplication over addition or subtraction of rational numbers. The rule of an examination was that each correct answer would be awarded plus 2.5 marks and every wrong answer would be given minus 1 by 4 marks. If Chetan gives half correct and half wrong answers out of 100 questions, how many marks will he get? Out of total questions, Chetan gave half correct and half incorrect answers. That means he gave 50 correct and 50 wrong answers. A correct answer is given 2.5 marks, that is 5 by 2 marks. In this way, he will get 50 multiplied by 5 by 2 marks for 50 correct answers. Similarly, minus 1 by 4 marks for 1 wrong answer. In this way, he will get 50 multiplied by minus 1 by 4 marks for 50 incorrect answers. In this way, he will get total marks 50 multiplied by 5 by 2 plus 50 multiplied by minus 1 by 4. By simplifying it, we will get 25 multiplied by 5 plus minus 25 by 2 marks, which is equal to 125 minus 25 by 2 marks, which is equal to 250 by 2 minus 25 by 2 marks is equal to 225 by 2 marks, which is equal to 112.5 marks. Since the sum of rational numbers can be distributed on a multiplication, a multiplied by b plus c is equal to a multiplied by b plus a multiplied by c. Therefore, we can also write 50 multiplied by 5 by 2 plus 50 multiplied by minus 1 by 4 as 50 multiplied by 5 by 2 plus minus 1 by 4 in this way. Simplifying it will result in 112.5 marks. Therefore, Chetan will get 112.5 marks in the exam. You can see that we have got similar result from both methods. Let's see the next example. Vaishali has 1240 rupees. Out of these, Vaishali spends 3 by 5 part of the money to buy books and 1 by 4 part of money to travel. So, how much amount does Vaishali have left? Vaishali had a total amount of 1240 rupees, out of which Vaishali has spent 3 by 5th part for buying books. Hence, the cost of buying books is equal to 3 by 5 multiplied by 1240 rupees. Similarly, Vaishali has spent 1 by 4th part for travelling. So, the amount spent for travelling is equal to 1 by 4 multiplied by 1240 rupees. Hence, the balance is equal to total amount minus the cost incurred in buying books minus the cost of travelling. Balance is equal to 1240 minus 3 by 5 multiplied by 1240 minus 1 by 4 multiplied by 1240 rupees. From the distributive property of multiplication over subtraction, balance is equal to 1240 into bracket 1 minus 3 by 5 minus 1 by 4 rupees. We will simplify it in this way. Therefore, Vaishali has total of 186 rupees left. Let's see the next example. Using appropriate properties, find the values of 1 by 3 multiplied by minus 2 by 5 minus 1 by 7 plus minus 2 by 5 multiplied by 5 by 3. The addition is commutative for rational numbers, so we can put these two operations together. From the distributive property of multiplication over addition of rational numbers, we will take minus 2 by 5 out of the parenthesis and thus simplify it. Now, to simplify this bracket, we will make the denominator same for both numbers. By simplifying it, we will get the result minus 33 by 35. So today we have seen some examples related to distributivity of multiplication on addition and subtraction of rational numbers. We will see some mistakes related to them in the next video. Today we will see some common mistakes related to distributivity of multiplication on addition and subtraction of rational numbers. Mistake 1. Incorrect distribution of multiplication over addition or subtraction. Some children often make mistakes while distributing multiplication over addition or subtraction. This is more commonly seen in algebra. For example, if children are asked to distribute 1 by 7 into bracket 2x minus 5, then children write it as 1 by 7 multiplied by 2x minus 5. They do not multiply the number outside the bracket with both the numbers written inside. They only multiply it with the first number. Remember that to get the correct answer, it is necessary to multiply the number written outside the bracket with all the numbers written inside the bracket. Mistake 2. Confusion between associative property and distributive property. Some children have confusion between associative property and distributive property because both properties are related to the use of parentheses. If they are asked which property is used in this equation, then Looking at the parentheses, they tell that the associative property is used in this equation. It is necessary to understand that the addition is distributive over multiplication here. Let's understand this mistake with simple example. Suppose 5 guava and 3 mangoes are kept in one bag, and if there are 7 such bags, what will be the total number of fruits? We can add the number of fruits in the bag and then multiply these by 7. That is 7 multiplied by 5 plus 3. Or we can add them by knowing the number of guava and mango in all bags separately. Like 7 multiplied by 5 plus 7 multiplied by 3. The number of fruits will be equal in both ways. 7 multiplied by 5 plus 3 is equal to 7 multiplied by 5 plus 7 multiplied by 3. Here we have multiplied both 5 and 3 by 7, which means we have distributed addition on multiplication. This is also true in the context of rational numbers. Hence, the distributive property is used in this equation. Mistake 3. Ignoring signs of rational numbers. Some children do not pay attention to signs of rational numbers when using distribution of multiplication on subtraction. If children are asked what will be the result of minus 1 by 4 multiplied by 1 by 5 minus 3 by 5, so some children solve it in this way. This is wrong way to solve a question. The correct solution is as follows. Therefore, it is important to pay attention to signs when using distributivity. So today we have learned some common mistakes related to distributivity of multiplication on addition and subtraction of rational numbers. Today we are going to learn to find the rational numbers between two rational numbers. Let's play a game. In this game, we will take 3 squares. Only one number can be written in the first and third square, whereas in the middle square, many numbers can be written in it. The rule of this game is only those numbers can be written in the middle box whose value is more than the number written in the first square, but it is lesser than the number written in the third square. Means the value of numbers in the second square must be between the value of numbers in the first and third squares. So let's start the game. If the natural numbers in the first and third square are 37 and 41, then what natural numbers can be written in the middle square? Think. Absolutely correct. In this square, we can write natural numbers like 38, 39 and 40. Apart from these, no natural number can be written. Similarly, there are fixed natural numbers between any two natural numbers. Now suppose we write integers -3 and 3 in the first and third squares. Then tell which integers can be written in the middle square. Think. Your answer is absolutely correct. In this, we can write -2, -1, 0, 1, 2 integers. Apart from these, we cannot write any other integer. In this way, there are fixed integers between any two integers. Now, will you be able to tell that if we were to write the rational numbers between -3 and 3 in the middle square, then what would they be? Let me tell you, we can write -3 as -30 divided by 10. Similarly, we can write 3 as 30 divided by 10. In this way, we now have rational numbers between -3 and 3 as. Similarly, we can write -3 as minus 300 divided by 100 and 3 as 300 divided by 100 also. Looking at them, we can now say that rational numbers between them are. We can also write minus 3 as minus 3000 divided by 1000 and 3 as 3000 divided by 1000. Thus, we can now write rational numbers between them as. Similarly, we can find infinite rational numbers between any two rational numbers. That is, there are infinitely many rational numbers between any two rational numbers. Just think, can we call the rational number 7 by 2 as the rational number between minus 3 and 3? Think. Let me tell you, if A, B, C are three rational numbers where A is less than C, then B will be called the rational number between these two only, when B is greater than A but smaller than C. Here 7 by 2 is equal to 3 and 1 by 2, which is larger number than both minus 3 and 3. So we cannot call it a rational number between minus 3 and 3. Similarly, by comparing the values of numbers, you can find out if a number falls in between the given numbers. This comparison can also be done on the number line. Let us now learn some interesting methods of finding rational numbers between two rational numbers. Suppose we have to find rational numbers between 2 by 9 and 6 by 7. For this, we will first make the denominator the same for both rational numbers. Since LCM of denominator 9 of 2 by 9 and 7 of 6 by 7 is 63, therefore, we will multiply numerator and denominator of each rational number by a suitable number to make the denominator of rational numbers as 63. With this, we get an equivalent rational number of 2 by 9 as 14 by 63 and 6 by 7 as 54 by 63. Now, the rational numbers written between are like this. Now, let's learn another interesting method of finding rational number between two rational numbers. We will understand this by finding rational numbers between 2 by 9 and 6 by 7. First, we will represent these rational numbers on the number line. On the number line, dividing the distance between 0 to 1 into 9 equal parts, we can show the number 2 by 9 by taking 2 of these parts. Similarly, we can divide the distance between 0 and 1 into 7 equal parts and take 6 of these to represent the number 6 by 7. Now, we will find out mean of 2 by 9 and 6 by 7. Mean of any two rational number A and B is A plus B divided by 2. In this way, we will divide the sum of both rational numbers by 2. Therefore, mean of 2 by 9 and 6 by 7 is equal to 34 by 63. This is the rational number between 2 by 9 and 6 by 7. In the same way, can you find the mean of 2 by 9 and 34 by 63? Try stopping the video. Let me tell you, we will do this as follows. This will give the rational number 24 by 63 between 2 by 9 and 34 by 63. In this way, we can find infinite rational numbers between 2 by 9 and 6 by 7. So, today we have learned how to find the rational numbers between two rational numbers. In the next video, we will see some examples of these. Today we will see examples of finding rational numbers between two rational numbers. The teacher asked Arnav to find three rational numbers between 7 by 4 and 9 by 4. Arnav answered 2, 15 by 8 and 19 by 8. Find whether Arnav gave the correct answer or not. To find out whether the answer given by Arnav is correct or not, we have to see whether all these numbers fall between 7 by 4 and 9 by 4. Can you tell us how to do this? Think. Let me tell you. If A, B, C are rational numbers where A is less than C, then B is the rational number between these two only when A is less than B is less than C. B is greater than A but smaller than C. Here 7 by 4 is less than 9 by 4. In this way, here we see that in 2, 15 by 8 and 19 by 8, each number is greater than 7 by 4 and smaller than 9 by 4 or not. We can write 2 as 8 by 4. In this way, we know that 7 by 4 is less than 8 by 4 is less than 9 by 4. Means 2 is between 7 by 4 and 9 by 4. Is 15 by 8 also the rational number between these two rational numbers? Think. Absolutely true. If we write 7 by 4 as 14 by 8 and 9 by 4 as 18 by 8, then we know that 14 by 8 is less than 15 by 8 is less than 18 by 8. Therefore, 15 by 8 is also rational number between 7 by 4 and 9 by 4. If we talk about 19 by 8, then this is greater than both 14 by 8 and 18 by 8. Therefore, this is not the rational number between 7 by 4 and 9 by 4. Therefore, Arnav's answer is wrong. The rational number between 7 by 4 and 9 by 4 are 2, 15 by 8, 17 by 8. Next example. Find 10 rational numbers between -4 by 11 and 2 by 3. Let's solve this by reviewing each method. We will take the denominator of -4 by 11 and 2 by 3 similar. For this, we will multiply numerator and denominator of -4 by 11 by 3 to get its equivalent rational number -12 by 33. In this way, equivalent rational number of 2 by 3 is 22 by 33. Now we can say that the rational numbers between -4 by 11 means -12 by 33 and 2 by 3 means 22 by 33 are -11 by 33, -10 by 33, -9 by 33, -8 by 33, and so on, 19 by 33, 20 by 33, 21 by 33 are like this. Take out any 10 rational numbers among these and answer the question. Next example. Find out the mean and 3 rational numbers between rational number 5 by 12 and 7 by 18. Mean of any two rational numbers a and b is a plus b divided by 2. In this way, mean of 5 by 12 and 7 by 18 is 29 by 72. Now, you pause the video and try to find the mean of 5 by 12 and 29 by 72 by yourself. You will get the answer as 59 by 144. In this way, we can find out the mean of 29 by 72 and 7 by 18. Their mean will be 29 by 72 plus 7 by 18 divided by 2 is equal to 19 by 48. In this way, 3 rational numbers between 5 by 12 and 7 by 18 are 59 by 144, 29 by 72 and 19 by 48. Now, find yourself the 3 rational numbers between 14 by 5 and 9 by 11. So today we have seen examples of finding rational numbers between two rational numbers.